Cones, second to last section here. So cones follow the exact same formulas as pyramids, but they have circular bases. Let's make sure, again, guys, nothing else is in front of us besides calculator, pencil, note sheet. So cell phones, headphones, all that business, put away. I'm not going to have you write all this vocab down because you have a picture and we've gone over most of it, but I think it would be worth writing down what a cone is by definition. So a cone is kind of like a pyramid, but it has a circular base, and then it has a vertex that's not in the same plane as the base. So it doesn't necessarily have to be directly above it, like in the center, but it's somewhere above it. So there's some space up at the top where you can write definition of a cone. I won't have you write down all the vocab. You can kind of pick and choose what you want to write down. Yeah. I don't remember off the top of my head. My guess would be no because it's long enough as is, but I don't remember at the moment in time. Now, the rest of the vocab you can write down if you'd like, but most of it we've gone over before. Okay, your height, your altitude, so this is just like pyramids. We're going to have a regular height and we're going to have a slant height. Jared, can you put that away, please? Your regular altitude height starts at your vertex and then goes perpendicular down to the base. It'll only go to the center if it's a right cone. If it's an oblique cone, it would not go down to the center. The lateral surface. I didn't give you a note sheet. Well, then why didn't you ask for a note sheet?
Because you looked at me and then you kept walking.
I didn't do that on purpose, Jared. So let's calm down. Here you go. All right, lateral surface is everything that's not the base. So the lateral surface of a cone, if you pull it apart, almost looks like a little Pac-Man figure. It's like a full circle with like a little triangle cut out of it, basically. So then a right cone happens where the height meets the base, the center of the circle, right through the middle, and then the slant height will be important again. Even though it's like a rounded edge, it does have a slant height on it. So anything you see marked on the outside of the cone going down at a diagonal, that would be your slant height. And then anything you see marked perpendicular in the cone up and down at a right angle, that would be your normal height. So just like pyramids, we're going to use the slant height for surface area, and we'll use the normal altitude height for volume because it's on the inside. Okay? Okay. So surface area of a right cone is literally the same formula. So here was the surface area of a pyramid. I can remember it. Okay, that was your formula for surface area of a pyramid. It is the exact same formula. The area of the base, well, for a cone, the base is always a circle. It looks ovular, you guys. It looks like an oval, but it's not an oval. It is a perfect circle. Since the base is always a circle, we just plug in pi r squared for b, because we know it's always going to be a circle. And then this 1/2 the perimeter, the perimeter of a circle is the circumference, 2 pi r, and if you take half of 2 pi r, you're only left with pi r, and then times the slant height. So it is literally the exact same formula. We're just plugging in things for the circle. Which makes it a little bit easier for you guys, because then all you guys need is the radius and the slant height. You don't have to worry about the capital B and computing that. Do you all have this written down for surface area? At the top of your note sheet, formula for surface area of a cone. Delaney, do you have this written down? Okay. So L again stands for slant height. That's the height on the outside of the cone. Now these cones, we're thinking of like sugar cone, like ice cream cones that are sugar cones, which got me into a very interesting discussion my first year teaching, because nobody knew what a sugar cone was. They were like, no, you're talking about waffle cones. I was like, no, it's different. Okay. What? Of a sugar cone? You can Google it.
Is it small?
Yeah, they're like little small they look like exactly like that, but they're small and you can buy them in the store. It's not a waffle cone though. I know the difference. And it's not a cake cone, like it's not a McDonald's cone. I know what that looks like too. I eat a lot of ice cream, so I know exactly what all the cones look like. Okay, can I keep going? Here we go. First problem. Here's your formula. Pi r squared plus pi rl. Oh, somebody brought up last hour too that they put just a capital S instead of SA. I put surface area SA. I guess I don't know why, just to make sure that you know that's what I'm talking about, SA, surface area. So if you see this, it means the same as surface area, just so you know. All right, our R. Let's go. Jake Walker, what's the radius of this cone? The radius of the base? 4? And then your slant height is 6. See how it's marked on the outside going at a slant? That's how you know it's the slant height. So then from here, we just plug them all in. Pi times 4 squared plus pi times 4 times 6. What do you have to do first? Seth? You have parentheses, yes, but you have to square first, whoever said that. So pi times 16 plus pi, I can go ahead and multiply that right now. 4 times 6 is 24. Okay, so I'm going to write it exact, and then we'll write it as a decimal after that. So remember back to cylinders, when we write it exact, you just add your like terms. So add 16 and 24. 40. So we can write it as 40 pi inches squared, or what's 40 times pi to a decimal? The nearest decimal.
125, 7.
Wait, what?
7.
Inches squared. Okay. Great. Try number 2 on your own, please. Okay. Let's go see what's the radius of the second problem.
7.8.
7.8, and then your slant height is 10. So then plug all that in, we get pi times 7.8 squared plus pi times 7.8 times 10. What's 7.8 squared, somebody? Jay, say it louder. And then I know 7.8 times 10, I just moved the decimal over, so that's going to give me 78. 78 plus 60.84 is...
138.84.
So you can write it like that. Or times pi, who got it as a full decimal? 0.1 meters squared. Great. Now, what do you suppose you could do? What if they gave you this height and they didn't give you the slant height? What do you think you could use there? That we used for pyramids too. Like, let's just say the 10 was not here and the 10 was there. What could you use to find the slant height? Pythagorean theorem. So if you get a problem on your homework where they give you the normal altitude height instead of the slant height, you would need to use Pythagorean theorem. Okay. Also, on your homework, if they give you the diameter, make sure you cut the diameter in half when you start solving your problem. All right, volume of a cone is also the same formula as a pyramid. So here was your formula for a pyramid, BH divided by 3. But again, your base is always going to be a circle for a cone. So we can just skip right to pi r squared divided by 3. There's your formula for volume. pi r squared h divided by 3. Now this one again, just like pyramids, this time you need the perpendicular altitude height on the inside of the cone. What? I haven't even skipped the slide yet. Hold on. Do we all have that formula written down? Okay, so finding the volume of this cone, let's go. Zach, what's the radius? And then your normal altitude height is 4.5. So plug that in, we get pi times 2.2 squared times 4.5 divided by 3. Don't forget to divide by 3. 2.2 squared, somebody help me out. 4.84? What's 4.84? Actually, from here, you should be able to type all of that in at once and get a decimal if you wanted to. But let's do it exact first, I guess. So 4.84 times 4.5 is 21.78. 21.78 divided by 3 is 7.26. So you can write it like that, 7.26 pi. Or as a decimal, I'm getting 22.8 centimeters cubed. I would accept either if it were a test. So even though it's an oblique cone where it's slanted, it still encompasses the same amount of volume that a right cone would. Okay, we're actually going to skip the next one and jump to the third one on the back. Can I keep going? Okay, so we're going to skip number 2 and jump to number 3. Okay, what is our radius here, folks? 5, but 8 is not the height. 8 is the slant height, which is different. We have to have the height to do these problems for volume. So we're going to have to use Pythagorean theorem here to solve for that perpendicular altitude height. So just make sure, like for a surface area, if they give you the normal height, you got to use Pythagorean theorem to get the slant height. And then for volume, you got to use it to find the altitude height. So I get x squared plus 5 squared equals 8 squared. 5 squared is 25, 8 squared is 64. Minus 25 over, we get x squared equals 39. Square root. What's the square root of 39? Nearest 10th. 6.2. I went through that fast. Sorry, super fast Pythagorean theorem. A squared plus b squared equals c squared. That 6.2, that is the altitude that you need to find the volume with. And what would go in for h? Can't plug in h. That would give it too big of a volume. So make sure you have the correct heights. All right, pi times 5 squared times 6.2 divided by 3. 5 squared is 25. $25 times, oh, maybe not, 25 times 6.2 is 155. Divided by 3 is, I feel like something's not right here. Oh, we're good. We're good. Okay, 155 divided by 3 is 51.6 repeating, so you could write it that way, but this one might just be better off to go ahead and get it as a decimal. It just doesn't really look good when it has a repeating decimal with the pi next to it. So I'm just going to jump straight to the overall decimal. Okay, number 2 would have worked the same way. The radius is 7, the height is 13, and then you would have plugged it into your formula. But we're going to skip that for the sake of time. Are you okay with that decision? Questions on that? Okay, let's look at one of these problems that you guys quit asking me how to do them, because we've now done these problems a bunch of times and I keep getting asked how to do it. So A and B are similar. So we're going to find the scale factor, use the scale factor to find the ratio of the volumes, so like how they compare to each other, and then set up a proportion and cross multiply. Please make sure you're paying attention, guys, because if I have to explain this again, I'm going to pull all of my hair out. All right. Just kidding. I would not pull all my hair out. It took forever to grow my hair out. A and B, let's find the scale factor. 3 and 9. Okay, doesn't really matter what order you go in. 9 over 3 is fine. Then you're just going to work big over little for your proportion. You don't have to simplify it, but I'm going to go ahead and simplify it. It's an easy one to simplify. What's 3 over 9 simplified to? 1/3. Okay, that is not the comparison or the relationship between those volumes, though. So you cannot take 15 pi and multiply by 3. Which is what a lot of people are doing. That won't work here. You have to cube your fraction first, which is 1 over 3 cubed is 27, and now you can set up your proportion. I cubed 1 over 3. So then in 1 over 27, I worked small over big, so then I have to work small over big for the volumes. I don't know the volume of the big one. If I put the x in the wrong spot, then you end up with an answer smaller than 15 pi, which would not make sense. X times 1 is x. I'm going to leave this exact since they have the first volume exact. So what is 27 times 15? 405. So I'm just going to leave this as 405 pi. It's not the end of the world if you type it in and get the full decimal. But if they're going to put this one in terms of pi, then I should probably put the other one in terms of pi as well.
Or
405. We'll do one more real quick, and then you'll have some work time to do your worksheet.
So the pi just stays there.
Yeah. Yeah, and you could multiply and get a decimal. It's just we should probably leave it with the same notation as the first one.
So what'd you get? Oh wait,
Okay, so then the second one, what numbers would we use to find the scale factor? Who can raise their hand and tell me? Holly?
2 over 8 or 8 over 2.
Okay, I'm going to do 8 over 2. You can do 2 over 8, that's fine. What would 8 over 2 simplify to?
4 over 1.
4 over 1. Okay, but that is not the relationship. You can't just divide by 4 and get this volume. That would not work. You have to cube it first. 4 cubed is 64, 1 cubed is 1. And now you're ready to set up your proportion. Now I did big over little, 8 over 2, big over little, so I would need to do 384 pi over x. (64) times x is 64x. 384 pi times 1 is 384 pi. Divide by 64. What's 384 divided by 64? 6. So this would have a volume of 6 pi centimeters cubed. If you mess up your proportion, you would get a volume bigger than 384. And I feel like you could not argue to me that this little baby cone takes up more volume than this cone up here. They look like little Hershey's Kisses. They're like little spinning tops. Okay. Go ahead and grab out your worksheet. There's just a couple things I want to go over before I get a million questions. So for those of you that don't have it out in front of you already, grab your 11.7 worksheet out. We're almost to the end, guys. Look at this. We have one more section of notes. Almost to the end. Okay, so for surface area of a cone, here is your formula. So you need a radius and you need a slant height. Number 1 has both of those things, so you're good to go there. Number 2 has the slant height, but it gives you the diameter. So just tell me on number 2, if your diameter is 11, how long would your radius be? 5.5, and then your slant height is 7.2. So then you would solve from there. Okay, can't use 11. 11 is not the radius. 3 and 4 I don't have a picture, so they're a little bit hard for some people to see. Let's talk about 3 and 4 really quick. It says a right cone, so imagine you have this cone, has a radius of 9 and a height of 12, and I want to do the surface area. 12 is not the slant height, 12 is the height. So what do I have to do to find the slant height? X squared plus b squared equals what? Pythagorean theorem, yeah. So 12 squared plus 9 squared equals x squared, and then you would solve for the slant height. So your radius is there, your radius is 9, but you need to do Pythagorean theorem to find the slant height. That is the exact same thing for number 4. However, right, 4 gives you the diameter, so before you do anything on number 4, you need to cut that diameter in half. So the diameter is 11.2. What is half of 11.2? What is it? 5.6 would be your radius, height is 9.2, and then you're using Pythagorean theorem to solve for your slant height. Okay? Hi. Yes. And then you should be good to go. Those were the 2 biggest things that I saw. There's those. Are you guys gonna make it over here? Okay.